Today I'll be talking about how to name alcohols. So there are different types of alcohols. You have straight chain alcohol, like this one. I've made a model here. So this is considered to be straight chain, and this is the oxygen atom and hydrogen. So this is the OH group. So this is a straight chain, or it can be a branch chain, or you can have a cyclic alcohol. This is cyclopentanol. It has 5 carbon. This is the OH group, oxygen and hydrogen OH group. This is cyclopentanol, so it's a cyclic alcohol. You can have one hydroxy group, or you can have several hydroxy groups. So if it's two hydroxy group, it's a diol. If it's three, it's called a triol. In this particular case, since it's a ring, both the OH groups are on above the ring, and so it's called cis. But if the OH group was below the ring, one of the OH group is below and the other is above, then one is above the ring and the other is below. So you can see here, so one is facing towards you, the OH group, and one is away from you. So they are on different sides of the ring, and so this will be a trans diol. So the naming convention is straightforward and similar to other. So in case of the alkane, the E is replaced by OL. That's the naming convention for the alcohols. For example, if you have methane, the E of the methane is replaced by OL, and it's called methanol. Most important thing to remember is the ranking of the functional group, because that's important in finding out what the parent chain is. So if there's an OH group in the organic molecule, then the carbon chain bearing the OH group will be the parent chain. And all the other substituents like thiol is SH group. It's also called the mercapto group when it's a substituent, including the amine NH2 group, and you have alkene, which is the double bond, alkyne, the triple bond, and the halide. All these will be considered to be substituents on if they are the parent chain. So let's look at some of the functional groups which can be substituents on the parent chain. So as mentioned, you have the halides, fluorochloro, then you can have the alkyl like ethyl methyl, or it can be a ring like cyclopropyl, or it can be a double bond like ethinyl, or a triple bond or amino group, or a thiol group. In case of thiol group, when thiol group is the substituent, it's called the mercapto group. So let's look at the IUPAC names of alkyl group. I have covered this naming convention where in my video of naming alkanes, and please refer to that to better understand the naming conventions for these alkyl groups. So just to point out a couple of things, you have the methyl group, ethyl and propyl. They are all straight chain alkyl substituents, whereas these are all branched chain substituents. The common name is in the parenthesis, so T-butyl is the common name, and the IUPAC name is 1,1-dimethyl ethyl. Okay, and this carbon atom is attached to the parent chain, and so there are two methyl groups attached to this carbon, and this carbon atom is numbered 1, and so it's called 1,1-dimethyl ethyl. So C and CH3 is the ethyl. So let's look at the IUPAC rules for naming alcohols. So first important thing, locate the longest carbon chain that contains the OH group. This is considered the parent chain. All groups on the parent chain are considered substituents. We start numbering the carbon atoms on the parent chain from the end that's closest to the hydroxy group. We use the prefixes if the molecule has several of the same substituent, but remember that the prefix is not considered when we are naming the full molecule. For branch substituents, the carbon atom that's attached to the parent chain is numbered as 1. The prefix on the substituents is considered during the naming of alcohol. So whenever you have branch substituent, the prefix will play a part. If there are 2 hydroxy groups, then we use the prefix diol. If 3 hydroxy groups are present, then we use the prefix triol. And finally, to name the organic molecule, you have to list all the substituents in alphabetical order, preceded with the numbers to indicate the allocation, and then name the parent chain as alkanol. If the hydroxy group is attached to a ring, then it's called cycloalkanol. Let's look at some examples. So let's look at the first example. This is a tertiary alcohol because this carbon is attached to 3 carbons. Please watch my video to learn more about primary, secondary, and tertiary carbons. So in this case, the numbering is 1, 2, and 3. You could also number it from here 1, 2, and 3. It wouldn't matter. So the OH group is on carbon atom 2. pH is the benzene ring. So whenever benzene ring is attached to a parent chain, it's considered a substituent, and in this case, this is a phenyl substituent. So it's called 2-phenyl 2-propanol. Propane, because there are 3. The carbon chain is 3 propane. From propane you get the propanol because of the OH group. So if the OH group is attached, it's called the tertiary alcohol. We covered that. Let's look at another example. In this case, you locate the longest carbon chain that bears the OH group. So in this case, the carbon chain 1, 2, 3, 4, 5. So it's pentane, and because it's OH, it's called pentanol. And the cyclopropyl group is a substituent at carbon atom 2. So it will be called 2-cyclopropyl 2-pentanol. You have to make sure that you put the location of the alcohol OL. Okay. Let's consider this simple molecule. In this case, you start numbering from the carbon atom that's closest to the OH group. So you start with the carbon atom here. This is a primary alcohol because it's attached to a primary carbon. And the amino group is a substituent, so is a ethynyl group as a substituent. And so it's named 3-amino 3-ethynyl nonanol. Nonanol comes from nonane. Nonane is 9-carbon chain. And the naming is alphabetical order, so A comes before, and so amino is first and then is ethynyl. Let's look at this nice molecule. I have made a model of this. You have 1, 2, 3 hydroxy groups, 1, 2, 3 hydroxy groups, and 1, 2, 3 carbon groups. This is, its common name is glycerol. You'll find it in lots of different, it's a food additive, very widely available. Okay. So in this case, the naming was straightforward. You just write 1, 2, 3 propane triol. So if since there are 3 OH groups, you add the word triol at the end. If there were only 2 OH groups, you would add the word diol. and then 1, 2, 3 is the location of the OH groups. So let's look at some additional examples. So in this case, this is a secondary alcohol because this is a secondary carbon. Secondary carbons are attached to two carbons, two carbons. The numbering is from here 1, 2, 3. So you start with the end that's closest to the OH group. You do not start from this side. Okay, and then you have the double bond at carbon 3, and you have the more captor group at carbon 5. You also have a methyl group as a substituent. So you have you have two substituents, and the double bond is a part of the parent ring. So the naming is a little bit unique in this case. Of course, it will follow the alphabetical order. So you start with ME. R. Okay, so ME is same as ME here, and then you have R has preference over T. Okay, alphabetical order. You do not consider the di, which is a prefix. Okay, because it's not a part of the substituent. And then you put the number 3 to indicate the location of the double bond in, and then you put the location of the alcohol. Let's look at this example. In this particular case, this is the alcohol parent chain. Alcohol as a preference over the double bond. So you start numbering from the carbon that's closest to the hydroxy group, and this is the numbers you get 1, 2, 3, 4, 5, 6, and then this is the double bond is a substituent. It is the ethynyl group, and it's called 2-ethynyl 1-hexanol. Let's look at the next example. In this case, this is a primary alcohol, and the numbering starts from this carbon 1, 2, 3, 4. We have the methoxy substituent and the bromo substituent right here, and so we will name it alphabetically: 2-bromo, 2-methoxy, butanol. And then we have the last example. In this case, this is a cyclic alcohol because the OH group is attached to the ring, and you can see that this is hash and this is wedge. That means this is below the ring and this is above the ring. So the ethyl substituent is above the ring, and so this is trans. These two groups are trans, and you label. So the only substituent is the ethyl substituent, which is considered to be a part of the, so it's cyclohexanol, and then ethyl group is attached to the cyclohexanol. So it's trans 3-ethyl cyclohexanol. So that's the name. Thanks for watching and have a nice day. Like and subscribe.